Hello, everybody. If you want to join the voice chat, you can go over to the Discord. The link to the Discord is in the video title. If you are new, you can't just jump right on in. Random people just tuning into a live stream sometimes get in the voice chat. But if you've been a member of the forum for a little while, or if I know you, I'll let you talk. Anas is in the voice stream. Say hello, Anas. He muted himself. Anyways, Anas is going to... Sometimes I forget that people are asking questions. There he is. Sometimes I forget that people are asking questions. Anas is going to interrupt me every once in a while and tell me to read chat. But so this is the basic setup. We're back up. The thing I want people to stop doing is using FlowSrf to do stone layouts or any plugin to do their stone layouts, because what Rhino has natively with FlowCurve is better than anything anybody's ever developed in a plugin. And trying to do stuff with FlowSrf, I made the video thumbnail. Just where's the thumbnail? Okay, I put a sphere here, I put a disc here, and I put some stones around, and it turned into a baseball. And the spacing is not uniform anywhere on it, and that is just how FlowSrf works. Because this has a different... I don't want to get too far into it, but FlowSrf uses the model space, the UV space, to map things from here to there. And FlowCurve uses physical space, actual dimensions, to flow things back and forth. So that's why we want to use it. If you're not familiar with my Shank template, I've done a couple of videos on it over the years, but this goes down to my my basic idea of how I like to edit things. I like to edit things one at a time. So the general shape of my ring, if I want it to be wider, I edit that here and grab all of those. I edit the width here. If I want it to curve on the finger rail, then this flows from this curve. Okay, I guess I should do them one piece at a time. This is editing the general thickness, height. Then I come down here and I adjust how quickly I want those transitions to occur. So let me turn, why are some of these hidden? All right, so they're flowing from, this curve is flowing from this surf to this surf. So if I want, let's put a transition in here. Let's grab those points, move them over. Oop. Grab this curve, points on. And these base surfaces I never need to see. I'm looking at this. Now, if I want this transition to happen very quickly, I can move these together. So up here, it's just length by width. Down here is how quickly things move in and out. Over here, it flows from this curve to this curve with stretch. Over here is, do I want it to move at all? I can rebuild this curve. Let's just say 3.5. And then I can take and make this curve around. So as I'm trying to get a, shadow band to match another band, I have my basic shape, what my stone sizes are, how thick it needs to be. And then when I'm fitting it up against a scan, I'm just editing this one curve to get the fit right. Yeah, everything is just isolated into one specific thing while I'm editing. I don't try and edit everything all at once. I like it. It goes pretty fast, and everything uses history so that I can copy and reuse from one model to another. And the last thing I might edit is, let's say up here at the top, this is flat and I want my stones to kick out a little bit. you know, I want it to have this kind of shape instead of just a square shape up at the top. Well, that is this last couple surfaces right here. I will turn points on. Let me get these other points off. I will turn points on. I will grab them. I just redid this template. I'm not sure that I'm liking it right now because I put everything in the same row, but we're just going to turn those off. So I can grab these points and just say bend, bend. And I can take and give that a little bit of a bend right there. And then I'll take the last one and say bend. And that's kind of the end of the spine. Make sure preserve structure is on, which it was. And just bend it a little bit more. And now over here, we'll flip to the other side. You can see that it's now kicking out just a little bit. Why did I do this? Well, because if I need to change this, I still want to edit it symmetrically. I still want these both corners to tighten up. I just want to have an overall flow, an overall twist while still being able to do things symmetrically. There's a million reasons why I edit one thing at a time. Yeah. How do you link? I'm trying to find that chat. Okay, I see it. Brendan, if you're going to do text chat, just do it in YouTube because I've got that one up. And then if you want to do voice chat, you can do the voice chat one. How do you link the series of flowed curves to the curve that describes the curve of the shadow band? I'm not sure exactly what you mean, but this surface right here is flow curved from here to there. And then from here, I use FlowSrf to get it from here to here. So this is the length, width. This is the length and width of the shank at multiple different places. And then I take these curves and I position them down here. And then from here, I do a loft loose. And that loft loose gets placed over here, and then this gets flowed from this base surface to this surface. And I've made a couple of different videos about how I make this shank template, and I pretty much use this. Anas, can you remember the last time we did a job where we didn't use one of the shank templates? There's a few different versions, like there is for cathedral. So there's a template where it curves up. You know, the cathedral just curves up. There's open where it does not go all the way around. And the reason we need, like, I could make this not go all the way around just by bringing that back. Now it's not going all the way around. But on the all the way around ones, there is an extra curve, and we call them the tangency curve. So if I go down here, this is the tangency curve, and select objects. These two are the tangency curves. So what I'm doing is making sure that these two curves are exactly the same where it goes over the top, and the last two curves are exactly the same where it goes over the bottom. That way, let me undo to where that's back there. When I mirror this to the other side, I've got tangency between these two because basically there are four, nope, 2, 3, 4 profiles that are all the exact same size on top and bottom. And that way, when I join these up, they will be at least tangent C1 continuous. And down here at the bottom, it's the same thing. So this tangency curve is going to end up basically here, and then the end curve, the other end curve, and that. So that's why there's an open shank and a closed shank. The cathedral is an open shank that just goes up off the finger rail. So we've just got a blend target up here and a blend target down here. We make a blend between the two, and then it follows that path. But we can do the same thing, like moving it over, taking it from a square. We call it peel it open, where we make it go out like this, which just adds, just makes it look a little bit better when you're making rings. So Matrix Profile Placer makes this so much simpler and intuitive. Could not be more wrong, Newman. I'm sorry. What it will do is put another profile in that then you can use. It's using sweep one. All it's doing is using sweep one to create different profiles. But the way that sweep one works, if you are not doing anything other than a single profile, let me grab a curve here. If you're not doing anything other than moving a simple profile, copy and paste that, move that down. All right, this is great for sweep one. I've got one thing. I'm going to go around there. Did I grab the right thing? Yes. Okay. This is great for sweep one. Now you can rebuild this and make it do things, and you're great. As soon as you add a second profile to this, you cannot control the transition between one profile and the other. Rhino does it. You have to pick those settings ahead of time. If it doesn't work, you got to delete it and go back and start over. So sweep one profile, great. More than one profile. Let's throw a couple more out here. Let's take this and this, copy, paste, break, move from here to there. I'm not sure that's all going to line up. That should line up with the others. Okay, now let's do a sweep one. There's our rail, and there's our three curves. Oh, I'm just allergic to sweep one. I didn't even click it because I had more than one profile in front of me. Okay. Now, you cannot really control how this transition goes. So let's say I wanted this to have square corners. So I'm going to take and move that over. I'm going to take and move that over. And I want these square corners to start here. Well, you don't have control over that. You move it over here, and now it's changing the way this shape moves. You don't have... what are the options under sweep one? Okay. Global shape bending. Well, that's not what you want. Refit rail, I think you pretty much always do. I don't know. It's been a long time since I've touched sweep one. And by long time, I mean like 8 to 10 years that I have not used a single sweep one in a single model that I've ever done. Because every time I do, it comes back and bites me in the butt. Being able to add more and more and more profiles just means that you just have more things to edit in place. You don't have symmetry because that's not how Matrix Profile Editor works. So you're always having to make these silly kind of edits where you keep things, but I didn't want to move those control points. I only wanted to move the outside one. So now I'm doing this, and now I'm, trying to bump that over and do that so I can just move these and not the others. This is a horrible working experience. You will never get this as smooth as I get this because I'm using loft loose. And here's the analogy. This is how we edit curves, right? I'm going to move these to the other side. Move all these to the other side. All right. So the curve doesn't go through our points, but we can now move things and make a lot of detail right where we need it, and everything else is kind of smoothed out. This, turn points on for this. That actually, sweep one. It's probably because I've got do not change cross sections. When you're using matrix profile placer, you can't use do not change cross sections because each one of their profiles has a different number of control points. I have the same number of control points in all these curves, but as soon as I start doing something where I add extra detail in here, let's insert a control point, insert a control point there, and we're going to insert a control point there, and we're going to eyeball it to make sure that it's kind of the same, and we're going to do this. Now when we turn these points on, this becomes uneditable. Like there's just so many different control points in here. What that also means is it's going to be a lot more kinky of a surface versus down here, we have the same number of control points we put into it because we used loose. There's nothing extra. I can control where these transitions happen. I can edit symmetrically. I cannot think of a worse way to make a shank than with matrix profile placer. You end up getting in situations where you just can't get something smooth. If you have something like simple, then sure. But anytime sweep one exceeds one profile, you will be in trouble at some point trying to get something to be smooth and look like a piece of jewelry. Profile places the profile, so you would technically use loft after that instead of sweep. By the way, it lets you place profile that are mirrors of each other, so you get some symmetry. You get symmetry between X and you get symmetry across the Y. You get symmetry here. I'm very familiar with matrix profile placer. Okay. Which is more comfortable? Editing profiles flat against a C-plane, or editing a profile that's, because this is what it ends up doing. I want to take this, copy, paste, move that over to here, drop it down to here, and I'm going to flow without copying it, so it's over here. And now, where is it? There it is. Now you have to edit this thing over here. And you can double click it in Matrix and bring up something like this. Well, I already have this. I would prefer unroll to generate the flat surface from the ring cylinder. I believe this was made initially like 15 years ago with Create UV Curve. Create UV Curve. Now, I definitely do not like editing things in a cockeyed way unless I'm doing... I mean, there are some things that you have to build in place. I'm struggling to think of an example, but if I can, I'm building it like this so I can always edit flat. My gumball will always line up correctly with things. Over here, how do you move this up? How do you make this thicker? Well, I can manually set my gumball but then I got to snap to something. Oh, I can go over here and hopefully those two are at the same height. And then when I click here, that will get, all right, now I can move it up and flat. Usually you're eyeballing it and you get it a little bit off. Usually you're eyeballing it and then you're not quite flat anymore. You get some waves in your ISO curves. Yeah, it's just a miserable way to do it. I have full symmetry right here, doing it this way. And I can control how that propagates to the ring, how fast the transitions are, all of that. So no, Loft is the way to create a surface in Rhino. It has the most... It will never paint you into a corner. Every time I use Sweep, I end up regretting it, like almost immediately, to the point that I never use it for anything. This is how you edit curves. This is how I edit surfaces. If I want the middle to be wider, if I want this middle to be wider, I have to make it wider. And the points don't actually touch the surface. It's bigger. It's bigger than what it ends up being, just like if I want to make this curve go around, you don't actually have the curve points on the curve. This gives you the most flexibility and control. All right, enough about sweep one. Undo a bunch of stuff. Okay. I'm just going to move this back over to here, and we should be right back to basic. I'm going to rebuild this. Set wide there, make it flat. Okay, now we're back here. Putting stones on this. The only thing you should be putting stones on with is flow curve. And I'm going to start, this is a very simple example, and then the one from the thumbnail, we're going to do that one next. Okay. So here, I think I'm going to need 6 stones. So I'm going to do 6 stones here, and I don't know exactly how I want my spacing to be. We'll figure that out in a second. And now I need to get this from here to there. Well, let's break history on that. And Rhino has distribute. And I can say distribute. I want the spacing. I want a 0.25 millimeter gap between my stones. And this is spacing in the x-axis. Okay, so now all of these stones, if we come over here from the top and measure, will be 0.25 between the blocks. Okay, so I got my spacing squared away. I want to get it onto here. I'm going to pull out an iso curve. Off of here, let's toggle, go to there. All right, and now I'm going to do flow like you have all done flow before, which is flow rigid without stretch. We're going to go from here to there, and it doesn't work. Okay, it's upside down. If I take and I should have just set that back, because I do want to bend this from time to time to show why this did not work before and why you should pay for Rhino 8. Okay, as this goes, or as we rotate these end surfaces, let's bend those back. Bend. All right, these stones are not bending to meet the surface. They're upside down, just a general pain in the butt. So somebody's going to break out FlowSrf, and we're going to use FlowSrf and get them there. The problem is FlowSrf does not pay attention to spacing in a physical sense. It does it in the model sense with the UV. Well, here's the feature that's worth the price of admission for Rhino 8. I'm going to say flow rigid with no stretching. I'm going to click this curve right here, and then I'm going to click target surface. I'm going to pick this target surface, and I'm going to pick the curve. And now all of a sudden, the stones are curving around with the surface, matching up. And if I come in here and measure the distance between right there and right there, 266. I must not have clicked the right thing. Right there and right there. 256. All right. It's 2.5 here. It's 2.56 there from edge to edge. Flow curve uses physical space when you say don't stretch. Matrix is a lot more expensive. But even if it were free, I would not use it for stone layouts. Even if it were free. Because now I have something that will match. Now I have something that will update with my shank. Okay, my shank gets wider. My stones are still there. I changed the shape of it. My stones are still there. Matrix doesn't give me that. I got to delete it and redo my stone layout. Delete it and redo my stone layout. Delete it and redo my stone layout. I'm not interested. Also, because I didn't use stretch, when I go and measure the distance between these two, still not clicking the right thing. That point to that point, 257. I'm keeping my spacing the entire time as I go and edit this thing wildly. That's going to stay. All right, now the thing is, we don't actually put stones here on the surface. Matrix Gold is just a bug on wheels. They've got parametric stuff, but how often does it just crash? You know, Matrix was okay. Matrix Gold was a step down. I know that as Rhino added history, Matrix was able to add history. But when they added in the Matrix Gold stuff, it turned into a buggy nightmare. I have a copy. I own this. I've paid for it. I'm so frustrated with it. It's so much faster just to use history in Rhino. Where was I? Okay, this is not where we actually want to place our stones. We want our stones to be, let's say, I'm going to move this up like 0.3 to drop it. Now, here's the thing with flow curve. It measures the distance between things at this curve. So now when we come up here and look at our distance, now we are measuring from measure distance from this point. It's not on the curve. It's this point down here is where it gets measured. So it's measuring from this point. I'll get close enough to it to this point. All right. And if I would have gone a little bit further, that would have been the 0.25. What we care about is where our girdles are. So if we measure from this point here to that point there, that's only 0.2. So on a cathedral where you've got some reverse curvature and you've got these stones, what you will see when you're using Matrix Gold's parametric history is that you will get things farther apart here, and then when it goes back, you will get stones where you actually have girdles that touch. And you give that to your setter and he goes to put them in, and poof, that stone just gets busted because he had all of this space as he's going up, and then right here in this turn, the girdles touch. So we can address that. This is part of my template that was already in here. I snapped this ISO curve to show you guys, but in my template file, I have this curve. It is 0.3 millimeters below the surface because Rhino now has, we can extract an ISO curve from there, and then we can do offset curve normal. And it has history. So I can take this and say, I want it to be 0.3 millimeter, flip it because we're going inside, 0.3 millimeter. And now I have a curve that is history enabled. So I got too many things with points on down here. So I can take this and bend it back. Bend. that updated. So normal to the surface, normal to this line, it is going to be 0.3 millimeters below. I have that baked into my template because that's what I use. So let's turn this back on. Let's grab this, and we're going to do FlowSrf rigid, no stretch. Copy, rigid, no stretch, and we're going to go from this curve to this target surface to that curve. And I bumped that up by 0.3 earlier, minus 0.3. That pops down. And now we're back to measuring the distance between here. Whatever we have set down here, that's what it's going to be. Some of this works in Rhino 7. Some of it works in Rhino 7. Using join copy to do symmetric curve editing. It is there in V7, but it's not stable. And the one in V8 is stable. You can only flow rigid objects on the surface with flow curve. You can only flow rigid objects using a target surface. You can't do deforming objects. Let's do one of those. Okay, I'm going to bring in a cutter that is for the center line. So I'm going to import this file. That's the cathedral. Inline center line. There we go. Okay, now right now when you drag part of a template in, it doesn't update history when you open the file. So we're just going to say history update all, and now the center line is going to come and follow along here. I moved that way too close. Okay. It's got a little bit of tangency at the end for the center line, but anyways. Which is one of the problems of the way that we used to do center lines. We'd have to make it follow the same flow path as the other. But now, in V8, we can take the construction for this. Let's grab those guys. Yes. Yeah, I can just copy and paste. So this is something that was added in V7. It's copy and paste history. So there is history on this where if I go and move this, it's there's history from here to here to here to here. I can take and say copy, paste, and move all this stuff. And now I have a second copy of it. Over here, I still have history. The same history I had over here. That was added in V7 towards the end of the release cycle, right before V8, I believe. It is in V7, I'm sure of that. But that is, oh, that's a huge time saver when you're, blocks scale everything the same size. So if you want to have a bezel that is always an offset, you make one, you do an offset, you build your bezel, and now you can copy and place it anywhere in the file, change the size of the stone, and your bezel shrinks. It'll still be a 0.5 millimeter lip the entire way around. You don't have to have it in the block definition. Let's go ahead and throw this on. Let's go ahead and throw this on our stones over here. So I'm just going to move this from the bottom of there. Let's put it on top of our stones, right about there. Looks like a good centerline cutter. And then move it into place. Okay, so this is the end that needs to be on this side. So we're going to set X to right there. These guys have history. So we'll just break history on those. And then drop them off where they need to be. And I don't need that one, but sure, throw it in. And then this needs to be on the end. Set X to there. I'm going to hide these guys and then just loft this. Loft, boom, 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 boom. And we're going to loft loose. Tell it OK. I'm going to put this onto my cutter centerline surface. And now I'm just going to flow this onto here. Let's get rid of that one and show our shank back. So this, we're going to say flow, curve, and it's not rigid this time. But we still don't want to stretch it. We want to use physical space because I aligned this with the end of the stone. And we're going to grab that. And we're going to say our target surface is here. And can I see my curve? Yes, I can. And now this is going to match up with the physical distance that I have down here for a center line. All right, but wait, I wanted 7 stones because when I mirror this over, I want 13. Right now, if I mirror it over, I will have 11. Well, that's pretty easy. We grab that stone. We say select child, grab that one, copy, paste, and then we drag it down. We grab this and move it out of the way. Well, actually, so what I would do is probably go distribute, and I have this little macro where it's distribute, pause, grab all the things, tell it the spacing is 0.3 in the x-axis because that is my default for stone spacing. So, and I'm always laying them out along the x, so I can just have x built in. So that is why I can just grab that, right click, my stone spacing is fixed. There's the copy paste history that got added in. Then I want to grab my little centerline curves and just make that line up with the end of it. Maybe it needs to go a little bit further past the end where that last fishtail cutter would cut through. And there you go. All right. So this is kind of the basic one. There's a little bit of nuance in that this is bending or this is bending, and it handles all of that. Your spacing is always going to be 0.25 between, or well, 0.3 now because I just set it to 0.3. So when you come in here and you measure from girdle to girdle, that girdle to that girdle, we're going to be at 0.3. No matter if we have something with a little bit of reverse curvature where it gets spread out here and it gets pinched, you have a, and we'll hit the stone next to it, because you're laying it out at the girdle of the stone, the spacing will always be right. Okay. Now let's go to the dome, the cursed dome. Now, flowing from a dome is difficult. That didn't make a good thumbnail. I'll put the sphere in. All right, let's say the reason why it's difficult with a dome is I'm going to extract an iso curve. Now, when I do this, you can see everything comes to a point on this end, and then it gets bigger and bigger, and it comes to a point on this end. But in the opposite direction, it goes like this. So if I were to try and use an iso curve from a sphere, I would want to go this way with it, because at least it's kind of even. But no matter what you do, it comes to a point right here. So any surface you try and flow from, whether you have the points collapsed or if you use create UV, or whether you use create UV, like you just cannot get to this shape. Because on this shape, all of these points on the end are right there. This, they're all stretched out. No matter what you do. I'm going to do polar array here. Let's do 25. And I'm going to put those around. And select the new objects. Select new. Okay, well, new selection didn't get added. But I can grab its children. Okay. Take this and we flow rigid from here to here. Oh, I did not have copy on. You can see we've got a lot of extra spacing right here. I can make this taller. You can see what's happening because this is morphing it from this UV space to that UV space. And because you have all of this shrinkage of the U and the V right here at this point, well, over here, it doesn't have as much shrinkage because it's a dome. So it's going to be inflated here. And over here, where we have about the same amount of deformation in the UV, it's going to be fairly similar. But doing pave layouts like this is just a nightmare. Like, absolute nightmare doing pave layouts. Coming from a base plane to a dome. What you want to do is flow curve. So let's delete all of that. And if I want my stones to be, this is kind of what we would have for a dome. If I want my stones to be here, I'm just going to take and draw a circle about where they should be. The center of them should be, like something like that. And then I'm just going to say project to here. I can't get this from a extract UV, right? We have this way and we have this way. There's no way to get this. And I'll do the same thing. I'll do linear. Let's create 25 of them. I'm going to change the spacing no matter what it gives me. So I'm going to do like this. And now for this one, on the other, I said no stretching. This one, because we're going in a circle, we're going to want to stretch it. Because if I did just a straight, every stone has to be 0.25 between, or 0.3 between. Well, when you get to the end, did you magically pick the right number of stones and the right spacing where it's going to divide up this circle into perfect little chunks? Probably not. Anytime you have a stone layout that is continuous, like it's a closed curve, you want to use flow. Actually, I should go ahead and do offset normal, so I put them below the surface, but I'm not going to do that because it'll be easier with this on the surface to show you guys. So I'm going to do flow rigid stretch, and then I'm going to say there, my target surface is here, and this is my curve. Okay, and now we've got this extra space. So did I actually, I don't think I'm going to break these and then do automatic stone spacing where it's 0.3. So now at the surface, these have 0.3 millimeters of space, but we don't have enough. And it looks like we have like 2 missing stones. So what I can do is grab the last 2, say select children, copy, paste, and then move those guys down and rerun my automatic spacing. And now right here at the end, it's a little too tight right there. Well, that's why we use stretch when it's continuous. So let me select children, delete, grab these guys, and we'll do, well, here's the trick. I take one of these and put it over to here. And now I'm going to do distribute auto because I'm no longer worried about the actual spacing between these stones. We're going to stretch it and tweak it over here. So now I'm just going to do distribute auto on the X. I want everything but the curve. Distribute auto on the X. There we go. And now this curve point goes at the center of this stone, and this stone gets locked. I know I have the right amount of stones. Did I not break history on these? Why? Break history. Distribute auto on the X. Okay, now it's doing it. This curve point should be at the center of that stone, and it gets locked. And the reason is, as we go in a circle, that is representing this stone, but on the other end. So I'm going to grab these guys and say flow, rigid, stretch. So that's flow, curve, rigid with stretch on. There's my curve. That's my target surface. And go around. And now all of these have the exact same spacing between them. Is it enough? Measure distance. We go from there to there. 0.253. If that's not enough, then you take this and you say select child and delete. And you just run your distribute again. Distribute auto on the X. Now these stones all have equal spacing, and we can check and measure what that distance is going from that girdle to that girdle. Now it's 0.39. Whoa, 0.317, sorry. 0.317. So the first time we did it, we had 253, and now we have 317. Pick your poison. You want them a little close, a little far apart. All right, well, this is a pave. We need to do the next row. So I'm going to take and grab this guy's children, select children, and take that back out of it. And I'm going to group these. Group. And I'm going to do select parents, 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 parents. And everything but this dome, I'm going to copy, paste, and move up. Okay. Didn't mean to move this guy up. Let's move him back. And then let's scale him down. Okay. So now where do I want my next row of stones to start? Do I want it to start, well, we have way too many stones. So let's drag this back until we have about a good looking number. That's still going to be too tight. I'm just going to get in the neighborhood. And one of the ways you can get in the neighborhood is just take one of these stones and do an offset on it. So I'm going to offset off of here. I'm going to say 0.2 is my absolute minimum amount of space. So I'm going to do that. And then 0.3 is 0.35 is just like too much space. Now I have a min max. Now you just drag this until you're within that range between the min max. All right, and pick. Do I want this to be directly between these two stones? This one I should probably put, I'm going to mirror this to the other side. So I can take this stone and move it from here to between here and there. That's where the start is. And then down here, I have to decide, do I want it to end? Well, now it has to end between two stones. Set X between here and here. So now you just move this in one stone increments. Move one stone down. Okay, we're in our Goldilocks zone. So now how many stones do we have to get rid of? 1, 2, 3, 1, 2, 3, 4, 5. So we come to our last 5 stones, select children, delete. And you just keep going with this until you get your whole pave layout done. But sometimes you're not doing a circle on a dome. You're not following an ISO curve on your model. You just want to put something right about here on a surface. And so the way that I do that is, now if I just said flow regular to here, this is a very simple surface. Let me think. This is a very simple surface. Let me make a copy of it over here and flow that over and see if that won't give us a better example of what I want to show. Okay. You see how this is curving down? That's curving down. This is straight because we're coming from here, but if we were coming from this kind of surface, and I'll center it on the part, center of here. Oh, gotta break history first. Move from there to center of there. And you see you get this, I'm going to exaggerate it here, but you get this S shape. S shape. All right, you may not want that. So the thing that I've gotten in the habit of doing is just always flowing this as rigid. So I'm going to flow this rigid over to there so I get a straight line. And then I'm going to take that and go pull. I'm going to pull to here. And now I get a straight line on a curved surface. This is great for signet rings, that kind of stuff. And then this I hide away. I usually have a little junk layer. I don't have a junk layer, so I'll make one real quick. I just say junk. And then I'll tuck this away on a junk layer because I'm never going to need to see it. This is my control. This is my target curve. So dome curves, I purged. I don't have a target. There's my target layer. Set that on the target. And now I can just take a couple of these stones, copy, paste, take a line through them. Let's do tween here and there. And now I'm going to do flow without stretch. Rigid without stretch. Here's our target surface. There's our curve. Because I didn't stretch, this thing is actually too long. This is one of the pains of this. You always have to have an end of the curve that you want to work from. And if you're trying to work from the middle, a better thing to do would be probably be this. And you know, this is kind of an odd situation. Let's see, this is the start of it. So I'm going to say set X to there. Okay, this is the start of it. So I'm going to say set X to there. That's really weird. Okay. It's keeping the spacing between them, even though the curve's not long enough. I don't think I've ever seen this before. But we're just going to say select children, delete. I'm going to flip this curve 180. That is wild. Okay. I'm sure I could figure it out, but not right now. We're just going to reflow this. This curve and this curve, we're going to flow rigid with no stretch. Rigid, no stretch off of here. Target surface is this, and that is the start of our curve. That's where it goes. If you wanted to have this going the other, if you want to work from the center and have it going the other way, you just take all of this stuff, copy, paste, and then take this extra curve and just rotate to there. What did I not copy and paste? I did not copy and paste the junk. You always have to copy and paste your junk. I've got two of them. Undo before the paste. I have tried to talk to McNeil about this. If you want to add to people saying that copy and paste for doing copy and paste history should include things that you can't see, which is the way Rhino is supposed to work, then that is this guy. So Rhino has a normal way that it works, and when it comes to copy and pasting with history, it doesn't work like that. So this is the thing. Nobody ever complained about it but me, so it's still sitting out here as an error. But there is a sample file in here you can download and play with this. But basically, if you copy and paste and one of the things is turned off, it says it's selected up here in the command line, and then you copy. And when you paste, the thing that it said up here was in the command line. When it pastes, it's not there. It'll paste everything but the things that were hidden. Doesn't make a lot of sense for copy and paste history not to include some of the things that you're wanting to copy and paste, but you know, I don't know. It never got fixed. I will put a link to this one in the chat and also add it to the video description. But yes, now that I have the junk included, this, and this, copy, paste, and then just rotate this 180. And they're not, that may be why I was having fun with that earlier. A single curve would have kept it all the way through, but then you have to work with, kind of shifting this to the middle of the curve. It can be a pain in the butt. Every situation is going to be different when you're doing this, but just know that flow curve without stretching, you have to work off of an endpoint. Like whatever distance. This is the other two. That's parents. Did not mean to grab all that. There we go. Those are the other two. Okay. Whatever distance you have between here and here, that's going to be your distance there. If you cut it in half like that and try and do that, this is morphing from UV space to UV space. So even though these endpoints are touching here, because I flowed them rigid, it's actually going to flow from the midpoint. The midpoint of this curve and the midpoint of this curve, and you see they don't line up over here. Every situation is going to be different. But this is a good way to get around things. If you needed to put, let's see. What would we want to put right here? I'm just going to reuse this shape. I'm going to copy, paste, break, history, grab this, and just say, if I wanted to put this on this sphere, well, Let's just imagine this had like, I don't know, this was a scroll or something. You're trying to put this on here. You're going to have a fun time with that. You're going to have a real fun time trying to get that onto a dome where you have all these squished UV points. What if move from there to there? Let's shrink this down to size. Now, this is a V8 thing, flow without stretch. I'm not using rigid because I want it to follow. Now we got it on that surface. There is no way you could pay me to try and go from here to there and have that be like, I don't know, kind of accurate. That just seems like it'd be a giant pain in the butt. I can rebuild this. Let's go 3, 5. And then I can take and start making this. Oh, I did the other one. Okay, let's rebuild this one 3, 5. And make it snake the other way. A little too tight of a turn for that geometry to take, but no problem. And are we sticking out past the end of the curve? No. Is the curve not long enough? Maybe. Yep. Okay. I can get from there to there. Putting a scroll on a dome, this is the workflow you want to be using. And this works very well. It's going to hug the surface. It's going to hug the surface exactly how it's supposed to. But we get to the next caveat when using flow curve with a target surface. It is measuring the target surface right here on this line. A single point along the line, that's where it's measuring. If you have something really wide, if this was really wide, right now it's pretty much hugging the surface. But if I take and make this fat, it's not going to be hugging the surface so well anymore because it is just using, oh, my headphone cord is in my Space Mouse. I knew it felt weird. Okay, you just go on top. Can't go on top. Doggone it. There we go. It's only measuring the surface curvature right there. So if you look, it's like up on this side and it's up on this side. That's because it's only a single point measurement. This is not FlowSrf. When you go from a curve to a curve, let's take and do, where's polyline? Oh, right there. Then let me make that like I actually intended to. Okay. When you flow this, let's do rigid stretch. From there to there, the curve only has a certain amount of information. It knows how far along, and it knows in what orientation is it to the curve. So this angle right here. But what you're missing between two curves is what angle is it this way. You don't have that. Okay, a curve only knows if something is the angle towards it and where it's at on the length. So things get weird when you start trying to rotate things. Now, without any other information to go off of, it's going to use the C-plane Z, the Z of the C-plane, to rotate these. But let's undo that and let's rebuild this where it can't really use the Z of the C-plane. I should have thought of a good example of this. It's actually holding together pretty good. It's actually holding up really well with just using the C-plane. I cannot think of an example of where this is a problem, but it is a problem. And if you've used FlowCurve for a long time, you've known that how this rotates around the curve is a problem because there's nothing to constrain it. Using this surface to control which direction is up, what is our up direction? Well, now we have everything we need. The curve knows when something's to the side, it just doesn't know where it is on the side. But having our C-plane direction being up and having a surface have directional information. See how our surface has little up red arrows? It always knows which way is up, the surface normal. That's what target surface is doing. It's mapping this Z to this normal, and now things rotate correctly. But it only does it right here at the curve. So your thing that you're flowing has to be narrow like a curve in order to fit. Okay. Do we have other questions? Oh, there's one other thing I wanted to show. Let's say I did have something that's wide. Okay, it's not going to work only measuring the surface right there. Not a problem. What you do is let me turn my junk back on. It is on. All right, let's go ahead and delete that. What I do is I make something with good UVs. Let's put that. Okay, I'm going to make a square because the best flow surface where you will never have any distortion is going from a square to a square of the same size. Any other shape, you will have distortion when you start morphing things. But I can get this kind of square shape, and I can flow it rigid from there to there. Get a square shape over here, and then pull it to the surface. All right, that can go on my junk layer and disappear. Yes, most of my templates are on GitHub, save for things that I made in the last year, Anas. Like the first 12 years first 14 years I was modeling is on GitHub and all the versions of them. But for the past year, I've been making my own tool, which you don't have access to. So those templates are kind of that's this templates R8 are not in there. You have the Leo and the you don't have Leo either because that's part of this. You have this templates folder. You don't have these two because it's a tool. Hopefully I get the tool good enough that I can release it one day. But the things that I'm doing in the tool that are not part of Rhino is you mirror this the Rhino way, you mirror it, and then you move this, and everything updates except your mirror, because the mirror is tied to a physical space. Well, in my tool, I have mirror tied to a surface, and it can do both of them at once. So now when I move this, my mirror updates with it. There's a bunch of stuff in the thing that is why I don't release the new template. But there's like all of these shanks minus what I'm doing now for mirror. Okay, we flowed this over here. We got this, and now I just need a patch. So what do we normally do in us? I'm having a brain fart. I think we'd go like this, and then we take this curve and flow that over. We flow that over rigid. That's okay. Anytime you're doing FlowSrf, like this button, show object direction, you click this and you click this, and then it will show you like how everything is laid out. So you know that their pink goes this way and your pink goes that way. Well, reverse the V, the violet. Okay. And their brown goes this way. And our brown goes this way. Reverse the ugly. And now this surface lines up with this surface. Direction analysis. Show just underscore dir. Yeah, underscore dir. Okay. I think we do this and then pull this to the surface. All right, we try and get this lined up with the square. We get it about there. And then I'm going to go ahead and copy this, copy that, paste, and then we're just going to keep putting these in until we get enough of them. And like this works no matter where you need this weird patch of yours to go, right? So no matter where this weird patch is, you can do this. You can kind of get these curves lined up with each other. I'm not taking the time to get these like really square. I could make these a little bit more even. You want them even because you don't want to have any distortion. But then you can do a loft right here. And for this, loft loose, the control points are not coincident with the surface. This you do. You want the control points to be at the surface, so we're going to do normal. And now you've got a surface that has a good UV layout for going on this dome. And I'm not going to lie, this takes a minute to get this to match up with a perfect cube or a perfect square. Let's hide all that. And let's show all this. Okay, this is not like the most straightforward thing in the world, but you can get this to match a square patch. And then this is your base surface. it takes fiddling. So I'll have this like over here and I'll be looking at it over here and like, where does this endpoint need to be to kind of match up with that corner? Right about there. And this guy needs to be, okay. I'm not going to waste time doing this because this is some of the most awful work on the planet, trying to get this to line up by square. But when you're done, you get a really clean flow surface where you can put, let me open up a file and I will show you one that I did for real, but you got to give me a second just to find it. So I'm going to put a little BRB. All right. I found one. Um, so this was getting, all right, this surface was a real big pain in the butt. But what I did is I made these fins that were in this nice square so that I could have, let's see, if we go to layout. Okay, so here's the surface where I got that on. Here's a patch on the shoulder of the shank where I got that on. Now, if I had, and trust me, I tried to use like all kinds of versions of this shank. The original quarter panel should be in here. Okay. So this is what the quarter panel initially looked like. And then we got, I got it to intersect with this dish in a perfect circle. Not fun, but it worked. Turn that history off. But here what I was doing is I took two straight lines and I did let's see. Let's turn everything on. Let's grab this surface and say, give me all your parents. Okay. So I started with the surface here and there, flowed that over. Why is the space mouse being wild? Okay. I flowed those over, got those two surfaces. And then I did tween surf. So if you've never used TweenSurf, it's like TweenCurve, except for surfaces. And right now, number of surfaces, one, let's say 5, so you can actually see them. Okay. Now that'll give me 5 surfaces between there. And then I just intersect these surfaces with that surface, and that's my loft normal. This is really, really, really slow if you ever have to update this shank, but it will update. It will have history. Did you smash to get the flat surface from the curved surface? Probably not. Oh, let's see. The question is, did I use smash to get this surface? And let's just take this guy and say smash. There it is. Oh, and it split it open for some reason. That's interesting. Did I pick an option when I did that? Explode, no. Keep properties, yes. It still did it. Okay, so I probably did not do that. What I may have done is like measured the length of this versus the length of that, and just made this where it was a little bit closer. But honestly, this looks like an unroll surf. Nope. You know, I could have just taken this, made a copy of it, kind of make it flat. Ooh, this is something I like to do. Grab a curve like that, figure out the length, 3.17. Just draw another one flat down here. That's 3.17. And then just take and flow curve this off of that curve to that curve. And it'll make it kind of flat in the middle, and then squish it. Break history. Squish the Z. And rebuild it to a 3-1. Let's see if this is close to, sorry, a 1-2 surface. Let's see if this is close to that. Kinda. I mean, depending where I would have put that UV curve, I might have gone from an edge, or it's not that big of a deal because you're pretty much square up here. So you just make a square shape, and if you need to change it a little bit, you change it a little bit. The point is you're starting off with a square shape. It's very easy to get your base surface off of a square shape. I could have left this as square, and it would have been fine up here. The other one that I did, let's turn all on. Let's grab this guy. Select all parents. Same setup. So I drew a curve that ended up being straight over there-ish. And then just did tween surface. Now, whenever you do intersections, projects, or pulls, those are like 20 times longer of operations than other things in Rhino. So this gets a little unwieldy. Like if I were to update this shank, we may sit here for a minute. Like if I were to change the shape of this, I mean, it had to do some work. It's not as fast as just changing something on that surface, like moving this, quick, easy. We didn't have to use project, we didn't have to use pull, we didn't have to use intersect. This is using all of those things multiple times. So when you do an update, it can take a long time for that to go through. That's the thing I'm trying to wrap my mind around, is all the transferring of curved surfaces to flat surfaces and vice versa. Yeah. So let me close this. Grasshopper is a good way to visualize how things move from one to the other. And I think the last time I opened up Grasshopper was making a definition like this. Visualize domain. There we go. Okay, and what does this want? A surface. Let's do set 1. Okay. And then what does this want? Set 1. Those are pretty... show me the dome. Let's do this one and this one. Okay, so basically this is splitting up the U and V and dividing it by a number. So these are supposed to be equally spaced. They are equally spaced in the domain. They're just not equally spaced in physical space. So, well, this is flat, so those probably are equally physically spaced. But when we come over here, there's, like in domain space, they're equal. Did I just get tired of trying to get Grasshopper to do it and write it? Yep. Object A, object B, reference object C. Set 1 surface. I haven't looked at this thing in a long time. I don't know. However this works, it's putting these equally spaced along the domain. And you can see everything just starts to come together at the poles, and at the equator, they're the most spaced out. And along this direction, they keep relatively uniform spacing. All right. Good. And if you have any more questions, Brendan, just you can ping me. And I did a video all about the universal shank that every single one of, you know, see if I can show stuff without leaking. Like, oh, weirdest thing that I use the universal shank for came up recently. I made this. What's it? Move to new window. This is the universal shank. That is the shank, and then this is. No, I ended up bailing on that. I was using like little shanks to go out here, but no, that's the shank in the center, and then these are. Gosh, it was like 2 weeks ago and I already can't remember how I made. Oh, it's just two curves, one projected to the top surface, one projected to the inner surface, and then lofting between them. Um, yeah, it's just a couple of curves being lofted together. I'm trying to think the last time we got that wasn't as crazy as I thought it was. I mean, that is the universal shank. I'm trying to remember the last time we got really crazy with it. Oh, the half bezel head in NOS. Uh, we turned it into a bezel. That weird half bezel that we did. Where, well, I mean, this head. So we were trying to make this head, uh, and we did it with the shank. And we had to do it with. We had to give it a surface target. Yeah, we did flow curve. We did flow curve stretch with this as the surface target to keep it facing the stone. Yeah, great example. All right, show everything. Select all parents. All right, go away. So this is just the shank template, and what we did is mirror it to the other half. And then there should be a curve. There's the curve. And it was flowed to this curve, which was just edited in place. So this does not have history on it. We can just take and edit this in place to get it to fit up to that stone. But to keep the flat side always facing the stone, we did flow curve with target surface. So this is the target surface, and this curve that I'm editing here is my flow curve. And I can't see chat anymore. There's no other good way of doing this. Like there is zero other good ways of doing this. This does not have to project to the surface. The surface just has to be in projection range so it can figure out the Z that this needs to go to. Because if I look at what the surface normal is right here, at this point, you know, it's going that way, which this has a slight. I gotta get a different. So wherever this curve projects or pulls to, I'm guessing it's right there. This is not level. It's actually angling down a little bit, which is fine. I want this to always, no matter which way we're looking at it, I want it to always point back to this dome. And if I didn't like where that was occurring, well, then I would just grab that curve and move it. And now it's pointing at, that's the normal. So this is my this is my independent control where I can change where all of this stuff is and the angle of it. And meanwhile, this flow curve is just hanging out over here. It just has to be in projection or pull. It has to be in a pull distance to the target surface. All right. Do we have other questions? Brendan, I've got your model. I might just do one-on-one with you on that because, yes, this is Rhino 8. The big thing in Rhino 8 is you have join copy that works without bugs. It was in version 7, but it had bugs where the seam would flip and just ruin like hours and hours of work. So that's what got me started. Like I made my own version of join copy in the end, which is how I'm doing symmetric curves like this. This is like my own flavor of it. Hopefully one day it's ready to release to the masses. And then the other thing, so I started making this while it was in Rhino 7. Rhino 8 actually fixed join copy. And if that would have been fixed, I wouldn't have developed my own probably. Because it's good enough. Flow target, flow curve with a target surface for non-rigid is only in V8. Let's see, new in V8. I mean, it's not a lot that is important to me in V8. Fillet surface to rail is something that I'm going to start playing with. Join copy is huge for doing symmetric curves. And the thing you do with join copy is you put a curve down. Then you create some symmetry somehow. Let's say we'll do 4. Okay. And then that symmetry has to end up on each other. Like they have to meet up. If I say these two are at the same X. Ow. Turn grid snap on. I picked like the hardest one to make this work. We're going to set Y to 3. We're going to set X to 3. And now these points can't move because I did rotational symmetry, but this one can. So you can make if these 2 points move, they have to move with scale 2D. You can't move these independently because I did rotate. But now, if you do a join copy, this guy, you get a new curve where all 4 of those are joined together. Ungroup this one. Okay. Then you take and feed that into curve through polyline. And you can say what degree you want it. I want that to be degree 3. I want it to be degree 2. Control point curve. And now your whatever kind of symmetry you can work up on a control polygon, you can get with join copy, and it's not going to flip your seam. It is in 7, but it will flip the seam. It's kind of terrible to work with in V7, so you need V8 for this. What else on the V8 list is worth its weight in gold? I am not a fan of the new menus and toolbars. They're kind of a pain in the butt to work with. Maybe they don't have as many bugs in them, because I was working with them when V8 was first released, and it was an absolute nightmare. I can't believe it got released. Macros is toolbar stuff, pain in the butt. Maybe it works better now. I'm so sick of touching it. I just refuse to change my toolbars, which I like to change my toolbars. Shrink wrap is pretty cool. Putting a surface over another surface. if we didn't use 3D coat, I would probably be using shrink wrap. Um, yeah, like the stuff that happened to Flow Curve didn't make it in the release notes, but I know I know deforming with target surface was in there. There were about a dozen blend bugs that were fixed. Um, there were a dozen blendbergs. This looks like. Oh, I don't think it's on the forum. I think I did it all privately with Miko. But this kind of stuff that always happened with blend surface in history. Um, well, there's still only 2 flow commands in V8. I just the number of options on them. Like this is flow along surf, but without preserved structure, and this is with preserved structure. So I have all of these flows with my own little icons to tell me what they do, but they're just flow curve and FlowSrf. Um, I just have this is rigid and rigid groups. This is flow rigid, no stretch, no preserve. I'm sorry. Flow surface, rigid no, preserve structure no, and then I have stretch and no. I have no stretch and stretch. This one is preserve structure, uh, no stretchy stretch, and then this last one is rigid, stretch no stretch, and the number of dots is the control point intensity. So if you tell it, yeah, just do whatever you want, it's going to make a ton of control points. You say preserve structure, and it's going to be limited control points. And if you say rigid, it's going to be the original control points. So, no, they just got more versatile since V6. Blend Surf had 0 history ability, even though it would try and update with history. And every single time, 100% of the time, if you replayed history on a Blend Surf, it would just wig out and be wrong. So, yeah, it having like these bug fixes were not a small thing. Those are all in V8. Uh, I tested about like 100 different scenarios with Miko, but I think that was all in private messages. Yeah, so that's not going to be in here. Um, Trying to think of other big things. They did a lot of work on Rhino V8. It's just most of it had 0 impact on my life. Sub D, don't use it. There's no history on it. You can't control your surface thickness. Um, no way. They do have some symmetry support, but it's not as good as what T-splines used to have. So no, I don't use any sub D. I do everything NURBS. Grasshopper had some interesting things added to it. I tried to use them, but they still had bugs when Rhino 8 first came out, and I have not gone back around to devoting the amount of time it takes to learn Grasshopper. I can't see anything else in here. I don't know. This is worth the price of admission to me. Like the first job, you have to do one of these, and you can just whip it out in 15 minutes. Um, Anas, you tried doing this one before you came to me. Do you remember how long you spent working on this before you brought it to me? Yeah, I wish I had one of yours that. Anyways, it's not right anymore because I've edited it and played around with it, but it ended up holding that stone and not coming loose, so it was right. I think that's the way it was originally. Turn the cutters off. I'm trying to remember this because this was like 2 months ago. Where's the stone? There it is. Okay, so we had a 3D scan. This is not where it was. It was something like that. I don't know. And we had the cutter. It all worked out perfectly. Stone fit in perfect. Set perfect. And yeah, it was about a 15-minute job. Without Rhino 8, I'm gonna I'm gonna spend 2 hours on it, not be happy, and then just have to hit print and let them try and fix it in the shop. So, all right. If there's no more questions, we'll go ahead and wrap this one up. All right. Well, that's it. All right. If you do have more questions, just jump into the Discord and we can look at them one on one, or you can ask them and I can answer them, whatever you want to do. All right. Later, guys.